I'm Elena May, and I'm part of Challenge 2016. For this video, Interactive Learning Assignment Bonus 1, I'm going to explain how we evaluate the series a of n is equal to n over n plus 1 to the nth power. So how we do that first is we're going to take the natural log of this. So it becomes n ln of n plus 1. Now, for us to evaluate it, we have to have a numerator and a denominator. And for us to do that, it's going to look at like ln n, let me write this, n plus 1 over 1 over n. So I just rewrote it. What we're going to do now is we're going to, this series is infinity over infinity. So what we have to do is we have to take the derivative of the numerator and the denominator so we can evaluate it. To take the derivative of ln n plus 1, I'm going to do it over here. Let's make sure, yeah, you can see on the camera. n plus 1. Alright, so I have a special method for evaluating the chain rule. ln of u equals 1 over u. And then to solve this, n plus 1, it is equal to, the derivative of this is equal to n, oh, sorry. It's 1 over n plus 1 squared. Now I'm going to circle this. This part is going to be substituted for u, so it's equal to 1 over n plus 1 times the derivative of n over n plus 1, which is 1 over n plus 1 squared, and this is equal to 1 over n plus 1. So we're going to plug it back up here. 1 over n plus 1, and the derivative of 1 over n is negative 1 over n squared. Now, what I'm going to do is I'm going to multiply this. So, I'm going to multiply this by negative n squared. Negative n squared. Just make a squiggle line to show our next step. So this is equal to negative n squared over n plus 1. We can simplify this as negative n over n plus 1. Remember, this is the limit as x approaches infinity. Now, this is still infinity over infinity, so we have to take another derivative. The derivative of negative n, is negative 1. The derivative of n is 1. So we see that as the limit of x approaches infinity equal to negative 1. Now remember, we took the natural log of this. So to undo that operation, we have to say it is e to the negative 1 to the negative first power, which is the same as 1 over e. And that's how you solve the problem.